Deepak, can you see the screen? Which screen are you seeing? That one? Okay. All right. So this is kind of the first step to actually learning about object. Like before we even get here, we needed to learn all those. So up until that point, any languages that you learn, you would probably have to learn up until uh, loops, right? And then object oriented programming starts. Do you guys remember which are the languages that are object oriented? Okay. Okay, C sharp. Right? I mean, most of the languages these days, right? So, uh, so object-oriented .NET is a framework. Object-oriented programming is very popular, and Java was one of the one that really did well, and that's why it was dominating the market for almost 20 to 25 years, right? Um, so what is object-oriented programming? And that's what we're going to understand today. Not really build a lot of objects, but try to understand what those are through a lot of examples, right? So let's see what the textbook says, and then we can do some examples for ourselves. So Java uses object-oriented, which is called OOP concept, right? A programming style that is intended to make thinking about programming closer to thinking about the real world. We have been, we are trying to do our best with the variable name as far as whatever the variable name, it represents, whatever the value is, your variable's name should represent that. So that's kind of an object, right? Instead of giving name like X's and Y's and things like that, you're actually giving appropriate name that represents that object. Um, in in object-oriented programming, each object is an independent unit with a unique identity, such as just as objects in the real world are. So, for example, an apple is an object. So is a mug. Each has its unique identity. It's possible to have two mugs that look identical, but they are still separate, unique objects, right? So mug in general, they're objects, but um, if you see here, you see how you have the attributes? Attribute could be the values that are represented by that object, and then your behavior. What does that object kind of behaves, right? So object also have characteristics which are used to describe them. For example, a car can be red or blue, a mug can be full or empty, right? And so on. These characteristics are also called attributes. An attribute describes the current state of an object. In the real world, each object behaves in its own way. The car moves, the phone rings, and so on. So everything that we interact with is there. Everything around us are pretty much objects, right? So when we are coding, we have to kind of emulate the same thing that we have been doing. And believe it or not, like when you toward the end of the course, when you see your code, you will not. Everything is familiar to you, right? Everything makes sense because there is no foreign code. You kind of read in your own library. You know how we're using a scanner and stuff like that? It will be your own library. It is something that you build that you're working with. That's why you need engineers. If the libraries were doing all that work, your business logic is your own business logic, right? So that's what we're gonna get to at some point. So the same applies to objects behavior. So attributes and behaviors is what you want to really focus on. Behavior is specific to the object's type. In summary, let's say an object programming, each object has three dimensions: identity, attributes, and behavior. Attributes describes the object's current state, and what the object is capable of doing is demonstrated through the object's behavior. So if you look at this image here, um, what do you think this object is trying to tell? What kind of object this is? Based on the attributes and behavior, can you name this object? Like a human, right? Or like a person, right? Someone who has a name, height, weight, gender, and age. That's your attribute. And then the behavior could be walk, run, jump, speak, sleep, right? So that's how you want to separate them. What makes a person and what can person do, right? That's pretty much it. If you can figure that part out, you can pretty much write any code base, right? So even by looking at the behavior and attribute, you should be able to guess what kind of object is that. Now, one person could be different than another person. That's totally fine, but we have that option. You can change the name. Everyone's going to have different height, weight, gender, but they're all going to have these things in common, right? So you have like kind of the common denominator, and then you have the changeable data. Data can be different, but the actual attributes and behavior doesn't change, right? So that's what we want to focus on when you think of object-oriented programming. So if you were to make persons, right, you can just create that, get that object, and you're really reusing the same code base to create different persons. That's all it is, right? Think of like, when you signed up to this class, right? Everyone signed up at a different time, right? All of you guys have one thing in common: you're all students, right? And you're all taking this class on Monday and Thursday nights, right? So there's a lot of common functionalities, and those are the things we try to trap them within the single object. But as far as who comes in when, that can be different. Who's paying when, that's, which amount, and all that stuff can be different. So those, when you isolate those issues, when you're able to understand that, then you can, like I said, you can write any program that you want, right? What's up?
You can use this also for machine like printer or
Yes,
scanner
yes.
like that.
Everything.
Change like models or
Mm-hmm. So if you
description
think of like
object,
this
and
scenario, right?
This can scan.
Right. So
print.
this is, this is, it has some of the common functionality like under the hood, but then it can be changed. Someone can have a home mode, someone can have a away mode, right? So someone could have a sleep mode. Same thing with your phone, right? One thing we know, they all make phone calls, but who you make calls to, that's different. Does that make sense? So, but the actual hardware still is kind of like copy pasting this thing, right? But what it can do, it has its own capability. So when we are writing program, that's how we have to behave, right? When you think of you're going to have scenarios such as, hey, a submit button. How many things can a submit button can do? You can check if it's visible. You can check if it's enabled, right? You can click on it, right? So let's say those three things that you're doing to a submit button, but the submit button itself doesn't change, right? So you're still interacting with the same attribute, but it can do different things. It can have a different behavior, so to speak. Okay. And we'll do this. We'll do so many examples that you're gonna have better understanding of it. Now, what is a classes? So that's kind of in high level what an object is, and then let's focus on what a classes are. We've already made a class, right? Every time we write a code, we create a class, which means a Java file. That's all that means, right? You create a Java file, and then you have to have a main method, and then you run your code, right? A class describes what the object will be, but in separate from the object itself. So in other words, classes can be described as a blueprint, a description, or a definition of an object. So we know an object, but there's no such thing as an object in Java, right? So how can you create object? What is the blueprint that we can use? So classes is what represents objects in Java. You can use the same class as a blueprint for creating multiple objects, right? So that's what it's saying, is that we can create one class with name, height, weight, gender, age, and then have some behaviors there, and we can keep using that to create different persons. Does that make sense? So it's kind of a blueprint, and that's why I like New York, because the houses are different. But when you go to Jersey or Virginia, all the houses looks the same. It's pretty much copy pasting, right? So they had one blueprint, and they just pasted on the entire neighborhood. All the houses looks the same. So, but it can have different characteristics, right? Some houses can have two-car garage. Some can have 4 bedrooms, 5 bedrooms, right? Different bathrooms, different colors, right? All of those things can be different, but the characteristic of or the actual house concept doesn't change, right? So each class has a name, and each is used to define attributes and behavior. Some example of an attributes and behavior. So that's what you got. In other words, object is an instance of a class, right? So let's create some class, and then we'll go through this image in a little bit. But let's create our first class and see what it can do. And we can create the same class that we are seeing here. We can do this one. And so we'll create a person. So this is, now you're creating an object, right? Every time you're creating a class, this kind of you're creating a blueprint for an object, and then we can use that and do a lot of different things. So let's do this. We'll say person, right? And then we can say, and don't worry about those keywords that I'm using, like private, public, and all of that. So name, height, weight, gender, right? Name, height, height. It could be double, right? The next thing was gender and age. Right? So these are your attributes. So now, every time I interact with a person, I can give them a name, I can give them a height, weight, gender, and an age. Make sense? Right? And like I said, we're going to learn creating, we're going to more details, but just based on what they're telling us to do. And then they're saying, well, you have to add some behaviors, right? So usually attributes are your field variables, right? And now we're going to focus on behaviors, which is your methods, right? So we're used to methods, but we only been used to one method, which is the main method, right? But now we are going to be creating methods that actually represents the object. So we'll say public void walk one. Okay, public void. Void. That's it. So you have your attributes, and then how we use them, we'll figure this out later, right? But for now, that's what makes a person. Some attributes and some behaviors, right? So for now, we'll just put some system out. Obviously, we cannot simulate OAuth right now, right? So walk. Start out. Right? So now you have all this. How do I actually call this person? How do I create that object? Right? So that's kind of the next step. If you wanted to access person similar to scanner, so think of like a scanner. Scanner was built similar way, right? Scanner had some attributes and some characteristics. They had some goals that they wanted to accomplish, right? So if we wanted to access this person, we can do something like this. Person, and you see where it says persons now available here? It's coming from basics, right? When we do scanner, it's coming from java.util, but when you do person now, it's saying, hey, you have a person within your own library, right? Person, so let's say, we'll just say, I don't know, John equals to a new person. So you just created an instance of a person, right? So person is kind of a blueprint, but this person is John, and John can have his own attribute, so to speak, right? But you can kind of perform what do you want John to do. So if you want John to run, it can run. If you want John to do other things that we have built, but see, everything is custom built now. So based on your requirement, you have to decide how to create those objects. Programming part sometimes becomes the easiest part. Like deciding those things, breaking down the requirements, focusing on tiny little details. That's the most difficult part for me when it comes to coding, right? Because the user really doesn't know how to give you everything, right? Because otherwise, why they're paying you? So it's kind of the main that's in engineering. That's one of the most difficult part. If you know what you have to do, you figure out how to code. That's not the hard part. It's mainly breaking down the requirements and identifying which one is an attribute and then which one's a behavior. And then once you figure, and we're not dealing with attributes just yet, today's not the class to do it, but this is how you'll create an object. An object must have an attribute, an object must have a behavior, and then if you wanted to use that blueprint to create a new person, then you will have to use it similar to how we've been doing for scanner and other ones. All right? Okay. So if we go back to this image now, so from programming concept, yes, this is, so the world seen by an object-oriented programmer, right? So when they look at TV, it's like more like, oh, entertainment provider singleton, right? And then you have a privacy manager delegate, living space separation decorators, right? Thirsty quencher that's the drink, an entertainment provider view controller, right? So it's kind of, and then you have what, a multi-butt supporter, right? And then you have the visitor monitor interface, the ones that you can see through, right? Indoor session initializer. So when you're writing this code base, is actually you're building the entire room, but it's been broken into different pieces, right? So every detail matters. If you think of this remote, right? Everything matters. What do you want each button to do, right? So, and then it has a behavior and it has an attribute. So attribute could be something like button, right? And I can give this button different value, and that's kind of the behavior of that button, right? So there's so many examples, right? When you get into a little bit of an experience of coding, everything you look around, like, oh, I can write the code for that, or I can do this, right? But we just need to get there with time. All right, any questions so far? you don't have to worry about the coding part. You understand what an object-oriented, like in high level. Guys look good? All right. So now the most fun part, right? So what are methods? So no, this is it gets easier now. The coding gets easier from now, right? If you're able to kind of finish that homework and then it's just moving things around. That's all it is. So let's talk about methods. So methods define behaviors, right? We have already done that. So if we go back to our person, these are your methods. We are used to main methods, but you don't see the word main anymore here. These are your custom methods. And these methods defines behaviors of your object, right? So we have to learn how to create methods. A method is a collection of statements that are grouped together to perform an operation. System out println is an example of a method. So println is an example of a method. How do I know? When you have this parentheses around it, that means it's a method. All right. As an example, you can define your own method to perform your desired task. So we've created some of these methods to perform certain tasks for us. We had walk, run, jump, so forth. So same way, what they're saying is, let's create this method and let's figure out why we have to create methods. So we're used to this public static void main, but this one is actually, we can't do much. This is for Java to run our code base, right? But if someone were to tell you, hey, can you print hello world 5 times, right? So you can do something like this. You can say south hello world. So let's say another instance, you have to do hello world again, right? So you can just keep going hello world. Or so let's say now, you decided to move to Mars, right? So now, well, wait a minute, I gotta change all of that code base, right? Let's say you say hello world like 500 times in your hundreds of thousands of lines of code base, right? How can you change all of that text? Are you gonna go through each of those files? Are you gonna miss some, right? You can break a lot of code base, and it's just chaotic. So what we are saying is, why don't you just create a method called hello world and just call that as you need it, right? So we can say something like public static void hello world, and then we can just say south. And every time you say hello world, it will just do a hello world. So this makes more sense, right? This is, you're just kind of keep using that. So even if you have to use it in 100 different instances, that's totally fine. You can just keep calling. You just can keep calling hello world, right? So run this code. For now, we have to keep public static, but this is going to be gone very soon. So tomorrow, even if you were to say, well, I'm going to change it from world to Mars, right? And then you can just refactor this name. So even if you call this 1,000 times in different code base, right? You just made one refactor and it will change it everywhere. What's up?
You obviously spoken that you just do static string hello world kind of thing. You can still do that. You cannot do that in this case.
But this is more. You can.
Static string.
But that's still hard coded value, right? That's more of an. In this case, we are dealing with a behavior, so to speak. If you're dealing with an attribute, now you can. It's kind of, you have to make a decision, right? Is this value going to continuously change? If that's the case, then you have to go with this. Static and final, let's pretend you don't know that yet. Okay? We're gonna go over why we have to use that, in later later classes. But for now, let's focus on the method and why methods are more convenient, and why do we use them. So this is how you create a method, and then this is how you call them and use them, right? If you want to call it from another class, like we've done here, right? So we'll split this, create some space. So if you wanted to get this one, it's not going to be available for you, right? You can't just say walk. It's not available for you. You actually have to create an object because you're getting data from another file, right? You're not accessing within the same family, so to speak, right? So when you go into another file, you have to do person, let's say John equals to new person, kind of how we do scanner, right? Scanner is not something built within your class, within your file, so you have to create an object of scanner to access them, right? So same here, if you were to create it within your class, you have an option to access them directly without saying sandbox.dat. That will pretty much work too, right? It's saying sandbox and then we are accessing this. But for now, let's avoid this. We're gonna go over this later and all those different rules. So now you really have to focus on some of those rules and stuff, otherwise you can't really access certain things even if you wanted to, right?
When we use the scanner, we have to import scanner.
Good questions, right? You don't have to import anything here because this is within the same project.
Okay.
Right?
If something we build the same project, doesn't make the package.
If it's within the same package, you don't have to import it. If you were to get it from a different package, even within the same project, you would have to
Same project, but different package, we must be
import it. Yes, and it will give you an option to do it. So don't worry about that. All right. So we've learned how to create the method. We've also learned how to call the method. So now let's focus on something called method parameters, right? Or arguments. So you can also create a method that takes some data called parameters, right? Along with it, when you call it, write parameters within the method parentheses. For example, we can modify our say hello method to take an output, a string parameter, right? So now we can even get a little bit more fancier, right? If you were to say every time, well, this is a good place to use this. Every time you log in, based on whoever the user is, we can say hello to that user, right? So previously, the way we've been doing, it's not so good. So let's say public static void So what they're saying is, well, method can do more than just performing an action. It can also take parameters and arguments, and based on the data you pass in, that's what it's going to do, right? So now, let's say if you wanted to say hello to the user, so you can say out. And we can create a local variable here. It's called local variable, and the scope is only within the method. So this variable is trapped inside of this method, and we can just say hello, and then pass in the argument here, right? So now every time when you do system.out println, you have to pass in a value to print it out, right? It doesn't. I mean, if you just have println, it doesn't really do anything, right? So get rid of this. If we do this, you see how it is? Like if you just leave it the way it is, it's not really taking anything. Whenever we supply a data in, that's what it prints. So now for you, you can print whatever you want to print. If I use it, I can print whatever I want to print. But under the hood, it's the same methods that doing the work, right? So we can do the same thing here with the hello user. Based on the user, whoever the user is, they can print their name. So we'll say, sorry, hello user. Now it's going to give you an error, right? The reason you're not getting error with println, there is a concept they use called overloading, which we're going to learn later, okay? So in this case, you can pass in an argument saying hello user to whatever the user name is, and that's called, let's say John, right? And now if I run this code, what do I expect to see,
Hello, John.
right? Right. Now, this is very convenient is that if we go back to our password validations, when you do username, you can actually have a method, right? And based on the username, when you say welcome to homepage and actually give the username there, right? So, and it's not just username. Think of when you log into an application, you see an image like an avatar, username, you know, and then all the other details related. We can supply all of that in every time someone logs in, right? So always try to kind of relate to real life. I mean, we all use web application these days or mobile. So just to see how they build it, you know, and things like that. And, you know, it will give you a little bit of insight of how this stuff works. Any questions so far? So far we know the methods can perform same task over and over, right? Methods can take parameters, right? But it's very important that method can take as many parameters it needs to, right? So like let's say I can say string address, right? I can say image avatar. Does that make sense? So we can do as many as we want, and it could be any data type.
We can also mix it string.
Yes, you can say int age, and you can say string name, right? Because age and name is going to be different for that user, right? So it doesn't matter, right? You don't want to kind of box into just doing one way. It's whenever you need to do certain things.
So why there's an error?
Good question. That's a good catch. Because I have two parameters here, but I only passed in one. Yes. So, but we don't have a code for the second one. Does that make sense? Because you see how this is grayed out. I don't have any code where the age goes, right? So we can say hello name, and then we can create that. Say your age is, and then pass in an age, right? So you see how the first variable, now you see how age, I didn't write this. This is IDE, the tool that you're using is supplying this data, right? So the first value should be age, right? Because it's telling you the first value should be age. So let's say 32, and then we can give. So the second value should be. So don't write this out. If you don't see this, that means you have some preference that is disabled, right? So, but this is not important. But don't write out name and clone and then put Mohammed, right? So make sure it's just the value that this is coming from IDE to help you what to enter, right? But this got rid of that error. Does that make sense? I forgot his name. Yeah. Darian?
Yes.
Yeah. Okay. So if you have two variables here, that means you have to use them, right? So that whenever someone calls it, they know what to enter. This gets really convenient. Like as you learn how to do this, you're gonna stick to coding. Or maybe I'm just too optimistic. All right. So method avoid. Method above takes a string call, right? We just talked about that. The advantage of using method instead of simple statement, including following, obviously code reuse, right? You can write a method once and use it multiple times without having to rewrite the code. Now, this is never going to come in interview question. Now, what is the method? Like, we expect you to know these things, right? So don't kind of prepare for interview. Just prepare in a way that you're learning something, right? So even anyone asks you this kind of stuff, you can kind of just answer it. And then you have the parameters. Based on the parameter pass, the method can perform various actions, right? So you saw how we were able to refactor our code, continuously refactor. First, maybe your person just had name. 2 months later, they wanted you to add an age or something. You can modify the same method, and everywhere it was called, it'll adopt that change and kind of take it from there. So this is the method signature. So this is called signature. What that means is you have, and there's a new thing that we have not gone over, and we're gonna go over in in a few minutes. So you have your modifier, which is public, right? And then you have your return type, which is the int data type, and we'll talk about what a return type is. And then you have your method name. So in our case, we have the modifier. Don't worry about the static word. And then we have something called void, which means it doesn't return anything, and we'll talk about it in a few minutes. And then you have your name, followed by a parenthesis, and then list of parameters. It could be one or it could be more. Now, if you see your parameters are getting like 5, 6, 7, 8, you're doing something wrong, right? It should not exceed, 3 or 4. Kind of like how if, all of that stuff we did. So we will simplify this. Like if it's growing too long, that means you have to simplify in a different way. We have to create it into an object and let the object do a lot of the work, right? But even though you can add as many as you want, doesn't mean you add 20 of them, right? Because then you're confusing the user a lot. Like, okay, it's just too much details going in here. Maybe this could be broken into a different object and in a sub-object and so forth, right? So that's in high level. This is how this is your body of the method, and then you have your return type. So let's go on. So now that we know a method can perform an action over and over, right? And then method can take X amount of parameters, right? And the parameters could be mix match. It could be int. It's a combination of int, string, image, table, person. It doesn't matter, right? As long as they're valid data type, it will accept it. That leads to method return type, and after that we can call it a night, right? So the return keyword can be used in method to return a value. For example, we could define a method named sum that returns the sum of its two parameters, right? So for instance, we have, let's copy paste this thing. It's also copying that. We'll get rid of this. So let's say if you want to create a method that adds two value and returns that after the computation, and returns that sum of those two values, right? So if you were to do this, this is not going to work, because now you want them to do the calculations and also give you back the result, and you can assign the result to another variable, right? So return is a very powerful thing, and again, most of these languages that you learn, it's gonna have this, right? So first, you're going to say public. We'll just keep using static, but don't worry about that right now. And then you say, okay, what is going to be the return data type? So let's say we are adding two int value, not double, just two int value, right? So the return type should be int. Excellent. So we'll say int, and we'll just say, call it get sum, and then the first value, right? So we'll just say int value 1, and then another one int value 2. And then we can just, so we can do two different ways, right? We can say, we can create another variable here called int total equals to value 1 plus value 2, right? And then we can use the keyword. Usually I like to use a space before I use the return, and then just a return total. So you see how this is kind of a template. If you ever wanted to add two values, right, you would use this template, just called get sum, and then it will add those. You just have to supply those two values, kind of like a calculator, right? You just add, you enter some data, and then you choose the operators, and then you enter the second value, and it adds it for you. So they have written similar type of code and just put that in the microchip or whatever, right? And it's performing the test. So here, I mean, we're not building that calculator, but we also have a method that can add two values, and you don't have to know how they are doing the computation. You don't have to understand addition, so to speak, right?
You don't have to do system analysis.
In this case, we are not doing that, right? But we can do it in later, right? For now, all you want to understand is that this method will carry out addition of two values. That's it, right? Any two values. And then after the computation, we are storing it into this variable, and then we are returning this variable, and we know that we are returning it. So every time you call getSum, so with these values, you see how hello user is? I can't store that value into another variable to do something else, right? So if I wanted to do something like this, string my value, it's going to throw an error because it doesn't return anything. And you guys have seen this a lot of times, right? When you do something like this, let me show you this. You see how you have different data types? Because these methods are all built with the return data types, right? So there are, every now and then, you will run into something called a void. In this case, it's not. You see how there's a void? Void means this cannot be reassigned to another variable. It just carries out an action and is done with it. Kind of like what we have with hello user, right? It just performs the action but doesn't do anything. But think about this. With this one, it's more powerful. It will do the computation first, and it gives you the result back to you, right? You can do anything else with the result. You can create another if statement based on the total value, right? So if you wanted to use this value, you can just call it, I don't know, like your salary total or something like that, right? So let's say int. Let's say you get salary from two different places, and you go to getSum, and then we'll just say 100 and 200. So now you got your salary here, right? And you use the sum method to add this, and then you can say if salary greater than 500, you can print out something like I am rich. Okay, I didn't say if it's 500 million or 500,000, right? So it's kind of, you see how you were able to do that, but this one is kind of a handicap, right? It can't really do anything. It just says hello users and it's done with it, right? And there are cases you have to do that. You don't want to return anything. But is that making sense to you guys? Right? So you can do any type of return value. Now, one thing I always like to return stuff, like, I can that use later on. So you can only return one final value. You cannot return like age and name together, right? It cannot return two things. Then that means you have to create two different methods. And we're going to learn how to do overloading at some point. But for now, let's say if you wanted to say hello world, but right after you say hello world, you want to return the name of that user. Maybe you want to do something else with it later down the road. Maybe every page you want to display that user's name, right? So you say hello world, but you also have an option to just return name. But it's going to throw an error because it says void. Did you say it's a void? Void means this method does not return anything, right? But in this case, what is the data type should be? All right, I think you guys got it. So, right, so now it will say hello, whatever the name is and your age, but I'm also giving you back the name. But you have an option to store this or just carry out, right? So in this case, we had to store it because, there has to be some objective of this total value. But let's say if you didn't want to do anything with it, get rid of this. It will still do the job, right? It will still carry out the action. You don't have to store it into another variable, but if you had to, now you have the ability to store the name somewhere, right? So you can say string username, and now it's going to store that name on that username value, right? Does that make sense? And then you can write more condition after that, right? If username dot equals full, you can say maybe a super user, right? So you're giving more customization with this stuff, right? So that's, you see how object-oriented can get really interesting and really complicated, right? So based on certain action, you want to get some value back in, and based on that value, you want to do some computations and so forth. They can go around and around. So don't make it complicated for yourself if you don't have to. Just focus on the requirement. If requirement requires you to do all of this, then you do it. If not, just first complete the task and then think about how you can optimize that code base. Okay, just because you write complex code doesn't make you a better programmer. If you simplify your code, that's what makes you, like if everyone can understand your code base, that's what makes you a better programmer. Okay. So that's for return type. So now we learn more things about methods, right? It can perform an action and we can repeatedly call it. It can take parameters. It can also do some computation and return that value into your method. And you can use that method to perform action and then also store that value into another variable, right? A lot. Method can do a lot so far. And method can also do a lot more as we kind of learn as we move forward. All right. I'll stop here, and the next class we'll go over classes and object, but let's just go over a few more examples on methods. I'm not comfortable.
You can use just only total or name, but it's written as total and name, yeah?
What do you mean?
Yeah, it's total. We can use other way.
What do you mean other way?
Like if we put int dot like int number dot, and we have option methods. Yeah.
Can you write it for me? Because I'm not understanding what you're saying.
Username dot equals, yeah.
Yeah.
We can use it also like.
Yeah, you can do it for total as well. Yeah. You can do the same thing for total. All right, let's do something realistic that we've done in the past. So we're used to this thing, guys. So let's cancel this out. So you guys remember this, right? We took a Fahrenheit, right? We took a Fahrenheit, and then based on the Fahrenheit, we did some computation. What if we had a method called get Fahrenheit? And then you pass the value of whatever Fahrenheit you want to see, and then also it will give you the Fahrenheit, yet also gives you the value back to that method. You can do something else with it, right? So if we were to do this, so we'll do this example. And method could be above main method, or it doesn't matter. It could be another class, it could be underneath, it doesn't matter. So we'll just say,
But you can access it anywhere in the project.
yes. Create a method converts So you want to do something like this: public static. What was the data type for Fahrenheit?
Double.
Right. Okay. And then you want to give a name that is more descriptive, right? So we'll just say get fair to cell, right? I don't want to put the whole. And then what type of data type? Because we need to pass in the Fahrenheit. A double, right? So we'll just say double. Fahrenheit. Okay. And then here we could just do the double, and that's your Celsius, right? Celsius equals to, and whatever the Fahrenheit the user passes in. To be honest with you, that's how pretty much, the application that you are using, that under the hood, that's what they built too, right? And all they're exposing is this value. This is the value that is being taken from the browser, and then it's computing it somewhere, right? And 5 divided by 9. And then you can just return this Celsius. So here's a little bit of a redundant. So now every time you need to do a Fahrenheit, you just. So when you do return, you can also pass that method inside of system out println. If it doesn't return anything, you cannot pass it on system out println, because the objective of system out println is to print something, right? And so it has to find some sort of value to print. So we can do something like this: out and get, and then you just say whatever. So that will do the job. Now you have a method that does that work. So if you were to go home and create a temperature object, and that temperature object can do any type of mismatch of calculation of temperature for, like, let's say Fahrenheit to Celsius, Celsius to Fahrenheit. So you have to create all the behaviors, right? But the attributes are Fahrenheit, Kelvin, and Celsius. So that's how you can identify. And we haven't gone to classes and objects just yet, so don't stress it too much. What I want you to do for now is create a method, and it's a very easy one. Create a method that converts Celsius to Fahrenheit to return the value. All right, so let's do that.